Welcome to this Amazon developer video on Amazon device compatibility and optimization. My name is Mike Hines, and I'm a technology evangelist for the Amazon Appstore. In general, Android apps optimized for a tablet experience will work just fine on Kindle Fire tablets. In this video, I'll walk you through what you need to think about while developing your apps for the Kindle Fire tablets in order to take advantage of the hardware and software features of the different Kindle Fire devices. First up, we will take a look at the device and feature specifications for each of the Kindle Fire devices. There are 5 Kindle Fire devices that your app can target. Both the first generation Kindle Fire and Kindle Fire devices have a 7-inch screen and are considered medium density devices. Both support 2-point multi-touch. In 2012, we released 3 new Kindle Fire HDs, a 7-inch device and 2 8.9-inch devices. The distinction between the 2 8.9-inch devices is one is Wi-Fi based networking, and the other supports both Wi-Fi networking and 4G LTE networking. All 3 models are considered high-density devices and support 10-point multi-touch. The 7-inch Kindle Fire HD supports HD resolutions of 720p, while the 2 8.9-inch devices support 1080p. Looking at the hardware across the 5 devices, all Kindle Fire devices support Wi-Fi and sport an internal SD card for data storage. All devices except the first generation Kindle Fire support Wi-Fi based geolocation. The 8.9-inch device with 4G LTE networking also supports GPS and assisted GPS location services. All HD devices also support a front-facing camera, stereo speakers, and Bluetooth HID and A2DP profiles. The first generation Kindle Fire supports Android API Level 10 or Gingerbread. All other devices support Android 4.0.3 API Level 15 or Ice Cream Sandwich. To improve compatibility with Kindle tablets, we recommend that you use APIs that are backwards compatible. Please use API Level 10 with the first generation Kindle Fire and use API Level 15 with all other Kindle Fire devices. Adobe Air is pre-installed on all devices, Air 2.7 for first generation Kindle Fire and Air 3.1 for HD devices. There is also an email client built into the device. Please note that in order for the email client to respond to intent, it must have been configured by the user first. Amazon provides a number of APIs that you can use within your app. These APIs can be grouped into 3 categories. APIs that are available for Kindle Fire devices only. Next, we have APIs that require the Amazon Appstore client. The in-app purchasing API can be used in any Android app distributed through the Amazon Appstore. Lastly, we have APIs available on all Android devices regardless of the App Store used. When developing for the Android platform, keep in mind that your apps may run on an array of devices that differ in screen size, hardware features, and software implementations. There are 2 different methods to determine what a given device will support: feature detection and device detection. Feature detection refers to making queries about a device's capabilities. Device detection refers to making a query that reveals the device ID of the hardware on which your app is currently running. We recommend you develop your apps to use feature detection first and only perform device detection when absolutely necessary. You can perform feature detection in several different ways, such as performing reflection, querying the package manager, or checking the result of convenience methods. For example, you can check if Game Circle is an available service on the device by querying class for name on the Amazon Games Client class. Similarly, an app may want to determine if a camera intent is available. In this case, you can use the Package Manager to determine if the appropriate software is installed on the device to make the request. To perform device detection, you can use the Android OS build object to query the manufacturer and model properties. Device detection is difficult to maintain, so you should only use it when necessary. Now that we have an understanding of the different Kindle Fire devices we can target, we will dive in to learn more about how you can make your apps compatible with these different devices. When you submit your app to the Amazon Appstore distribution portal, the app must pass some tests before it can be published. Apps should have a simple and well-thought-out user experience that does not cause user confusion, and it should be thoroughly tested and free of bugs, crashes, grammatical errors, and obvious defects. The developer portal provides a pre-submission checklist to help you understand what is being tested. We'll cover the majority of the points you should be checking in the next few slides. We'll cover unsupported features, permissions, and intents, user experience specifications, state retention after hibernation mode, using Amazon APIs, services, and apps, device orientation, app lifecycle functions, and Kindle 8.9 4G LTE considerations. To run on Kindle Fire devices, be sure that your app does not include any of the following: themes, wallpapers, screensavers, custom or third-party on-screen keyboards, please use the default on-screen keyboard instead, home screen widgets that manipulate the user interface, disable keyguard permissions, and lock screen customizations. Kindle Fire tablets support Android intents for launching activities like the camera and email. A full list of intent actions can be found at developer.amazon.com/sdk/fire/intents-supported.html. Every intent that your app utilizes that is not supported on Kindle Fire must be degraded gracefully. Like intents, support for permissions can vary by device. Disable keyguard is one permission that is not available on any Kindle Fire device. A full list of unsupported permissions can be found at developer.amazon.com/sdk/fire-testing.html. If you have functionality in your app that requires permissions not supported by the Kindle Fire device you're targeting, you must degrade that functionality gracefully. All ice cream sandwich-based Kindle Fire devices support Wi-Fi location services, and the Kindle Fire 8.9 with 4G LTE service can access location through GPS and assisted GPS as well. Note that the first generation Kindle Fire does not support Wi-Fi location services. Although only the Kindle Fire 8.9 with 4G LTE service can access GPS location services, using the Find Location permission in your Android manifest file will not break your app if it's included in other ice cream sandwich Kindle Fire devices. The user experience is very important. To help delight our customers, please make sure that your app occupies 100% of the screen. If your app fills less than 80% of the screen or is not centered, we will return it to you so you can fix it. The layout and UI elements, such as buttons, text input boxes, fonts, and images, should render correctly. Graphical UI elements should not be distorted, pixelated, misaligned, or have other graphical anomalies due to scaling or design issues. Input boxes should fully display the text that the user has typed without being cropped or otherwise unreadable. Also, touch targets should be appropriately sized. As per Android UI development guidelines, the touch area should be at least 7 mm by 7 mm. The objects should be easily identifiable, and please have at least 2 mm between tap targets to accommodate those of us with larger fingers. And please, all relevant gestures should be handled as per their standard behavior. Gestures like pinch, in and out, swipe, left, right, up, and down, and press and hold should work as expected. All Kindle Fire tablets support two-finger touch gestures. Kindle Fire HD devices detect 10 simultaneous points of touch and recognize two-finger touch gestures as supported on Android Ice Cream Sandwich. Your app can take advantage of the 10-point multi-touch capability of the HD devices and optionally implement custom touch gestures that use more than two fingers. On any Kindle Fire tablet, the user interface for your app needs to respond to the gesture patterns in this table. A list of standard gesture patterns is shown here, broken down by type of content, like maps or images, and where the gesture is initiated. For example, in the Chrome around your application versus within your application. Here we have an example of the Kindle Fire soft key toolbar that shows up on the bottom of the display in portrait mode and to the right of the display in landscape mode. Apps have the freedom to hide the soft key area, but essential functions still need to be accessible. For important actions, you should not assume that the end user will know to bring up the soft keys and invoke the overflow menu. Users must be able to use the Home button. Tapping it should take the user back to the home screen of the Kindle tablet. Use of the back, search, and menu buttons are not required. But when used, tapping these buttons should behave consistently with user expectations and should not cause the app to force close. The default behavior of the back button is sufficient for most apps because it returns the user to the previous activity. However, you can modify the behavior of the back button by overriding the activity on back pressed method in your activity. You can provide a customized search experience for your app by overriding the activity on search requested method in your activity. Any volume and mute functions built into your app should also function as expected. The soft key toolbar provides an overflow menu for additional commands that you want the user to access from the soft key toolbar. Commands like app settings, tasks that don't fit the current user interface, and global actions for your app are appropriate for the soft key toolbar's overflow menu. The target Android API level for the app determines the location of the overflow menu. With an Android manifest.xml as follows, an app on Kindle Fire, Kindle Fire HD7, and Kindle Fire 8.9 tablets exhibit the default behavior for API level 15, showing the overflow menu on the action bar. For the original Kindle Fire and API level 10, the overflow menu is shown on the soft key toolbar. Keep the following guidelines in mind when adding items to the overflow menu. Include no more than 6 items. The overflow menu doesn't scroll. Keep labels short because text strings don't wrap. The menu can expand up to 500 pixels wide before text is truncated. And please use title capitalization for all menu items. Here is a table of the most commonly used specifications. A full list of user specifications for device experience can be found on the developer portal at developer.amazon.com/sdk/fire/ux-specifications.html. For Kindle Fire tablets, hibernation mode is initiated in order to extend battery life after a screen timeout or when the user taps the power button. By default, hibernation mode disables all network connection and disables the CPU. When the device comes out of hibernation mode, your app should return to its previous state, saving all user data in progress. This can be done by overriding your activity's on pause, on resume methods, and implementing logic to save and restore state. To keep your app alive during hibernation, utilize the Android Power Manager and Wi-Fi Manager class to obtain a partial wake lock and a Wi-Fi lock. As best practice, Please release the locks when your app no longer needs them, and use a finally block to execute the lock release. Full sample code for implementing this feature can be found at developer.amazon.com/sdk/fire/samples.html. Kindle Fire devices do not support the Google Play Store or Google Play services. Your app should not reference or have links out to Google Play. If your app requires mapping, in-app purchasing, or notification services, Amazon provides APIs to enable these services. Information on how to integrate these APIs into your app can be found on the developer portal. The optimized browser shipping on all Kindle Fire devices is called Silk. Silk is backed by a WebKit rendering engine and provides support for HTML5, CSS3, and JavaScript. HTML5 video is also supported. Flash is not. Silk supplies one of two user agent strings in the request headers. The first is referred to as the desktop user agent. This user agent string indicates that the browser is requesting the standard desktop version of the page. The second user agent string, the mobile user agent, requests the mobile view of the web page. Each user agent string comprises several variables. You can detect the Silk user agent using some simple JavaScript code. At the Silk Settings menu, the user can choose among three requested view options: automatic, desktop, and mobile. On this slide is a sample JavaScript code for detecting the Silk user agent across all device families. Kindle Fire tablets allow for rotation of the display. To help ensure a good user experience, your app needs to account for changes in device orientation. The reference orientation rotation 0 for Kindle Fire tablets is portrait mode. Rotation 90 and rotation 270 correspond to landscape orientation. The default landscape orientation for first-generation Kindle Fire devices and Kindle Fire devices is rotation 90. The default landscape orientation for Kindle Fire HD devices is rotation 270. When creating an app for Kindle Fire tablets that runs only in landscape mode, you should specify sensor-based orientation in your Android manifest.xml. With sensor-based orientation, the system chooses landscape orientation or reverse landscape orientation based on the physical orientation of the tablet. Android API Level 9 and later supports this attribute for sensor-based orientation. Include the first sample in your Android manifest.xml file to specify that you want to use sensor-based landscape orientation. Alternatively, in your code, you can use the following constraint in the second sample. When your app is in landscape orientation on a Kindle Fire tablet, for example in a game, use display get rotation to check the display rotation when using raw accelerometer readings. The reference orientation for the Kindle Fire tablets is portrait mode, and the accelerometer readings are relative to a fixed coordinate system based on portrait orientation. You will need to translate the sensor data so that it makes sense for the current display rotation. That way, the logic in your app gets the expected input in landscape mode. For example, if you do not check the display rotation in a game, the game logic may move a character in the opposite direction than the user intended. Kindle Fire HD 7 and Kindle Fire HD 8.9 include a front-facing camera. When creating an app that uses the camera, you should account for the position of the front-facing camera to ensure that the camera preview and captured images have the correct orientation. Implement the following code to correctly display and save images in your camera app. Call camera set display orientation before initializing the camera to correctly orient the camera preview. Your app then needs to pass a rotation value that accounts for the current rotation of the tablet and the orientation of the camera. Call camera parameters set rotation from an orientation listener to ensure that JPEG picture callback receives a correctly rotated image. Finally, you need to call camera parameters set rotation because camera set display orientation affects only the preview and does not change the data provided to the JPEG picture callback event. When providing the rotation value to camera parameters set rotation, make sure to account for the current rotation of the device and the orientation of the camera. The application lifecycle is very important to understand for Kindle Fire devices. The best place to start is on Application Start. Ideally, the app will not take more than 15 seconds to install. If it does, it should display a loading message from the start. To help the app start quickly, please minimize allocations during startup, prefer static methods over virtual methods, load the smallest amount of resources required for the user to start interacting with the app, lazy load your app's dependencies when possible, divide title assets and load when needed, use persistent cache, avoid unnecessary use of thread synchronization, and use strict mode development tool to identify bad practices. The app launches on the Kindle Fire tablet and will advance the user into the app's interface without any errors. Apps should sustain a high frame rate without dropping below 25 frames per second for an extended period of time. The recommended average frame rate is 55 to 60 frames per second, especially for apps that involve fast-moving graphic objects. Apps should not throw exceptions, force close, crash, or hard lock while in use. Users should have the ability to change Kindle Fire tablet settings while running the app. Please ensure that your app is not consuming excessive battery power. Partial wake lock should be active for large downloads. Large downloads are those taking more than 5 minutes. If wake lock has not been implemented and the device has gone into hibernation mode, when the user returns to the app, they must be informed via message that the download has failed. This should not cause the user to lose state, cause a forced close, or impede the user's experience in any way. App activity should not impede the user's ability to interact with the app. For example, users should not experience a noticeable delay when typing into an app. Users should be able to navigate the interface of the app without becoming locked into any one screen. In addition, users should not be forced to exit the app using the Home soft key. Uninstalling the app should be quick and remove all artifacts, including saved data. Lastly, there are some specific considerations for the Kindle Fire HD 8.9 with 4G LTE connectivity. In addition to Wi-Fi connectivity, the Kindle Fire HD 8.9 4G tablet includes a plan for connectivity over a mobile network. By default, the tablet connects to Wi-Fi. If a Wi-Fi connection is not available, the tablet connects to a mobile network to allow users to download or upload files and data. The default data plan for the mobile network has a limit of 50 megabytes for any single data transfer and a monthly quota of 250 megabytes of transferred data. When the monthly quota is reached, unless the user upgrades the data plan, the connection simply shuts down until the next month's quota is available. To avoid exceeding the single transfer limit and to help users remain within their data plan limits, you should avoid streaming media or any sizable data transfers without first giving the users a choice of whether to proceed when the tablet is connected to a Wi-Fi network first. This includes background transfers as well. Your app must deal with a lack of connectivity gracefully and should alert the user when it's not possible to transfer data. Before your app transfers files or data, check whether the tablet is connected to a mobile network. In the following code, if "is Wi-Fi connected" is true, the tablet is connected to a Wi-Fi network. If "is WAN connected" is true, the tablet is connected to a mobile network. You can use the following code to initiate a Wi-Fi connection. Start Activity, New Intent, Settings Action, Wireless Settings. Now that we've covered how to make apps compatible, we'll look at Kindle Fire specific optimizations. To make your app optimal for Kindle Fire devices, please consider screen layout and resolution. Take advantage of hardware acceleration. Integrate Amazon Game Circle. Create immersive experiences with our stereo speakers on the Kindle Fire HD devices. Participate in the HD Designation program, and consider using deep linking to Amazon Appstore for additional items and reviews. Using a flexible layout. If you design your app for a specific device's screen, it may both look and behave differently than you expect when it runs on a device with a different screen size, aspect ratio, or pixel density. Specifically, apps designed for a device with a small screen may not properly scale up to large screens, or may look distorted or pixelated when scaled. Apps designed for a device with a specific aspect ratio may have distorted or overlapping screen elements on screens with different aspect ratios. Apps designed for a device with a specific screen density may have larger or smaller elements than you expect, which can affect both the appearance and behavior of your app. To address these issues, design your app to use a flexible layout. A flexible layout enables your app's user interface to dynamically scale to different screen sizes, densities, and aspect ratios at runtime. You can follow the Android best practices for designing an app for multiple different screen types, including create layouts using density-independent pixels, DP, rather than absolute pixels. The density pixel units have a baseline of 1 pixel per inch on a 160 pixel per inch, or MDPI, device, but are automatically scaled at runtime for devices with higher screen densities. Please remember to use scalable pixels when scaling your text. This way, the user choice of text size is reflected on the screen. Use Relative Layout Android class to build your UI so that elements can be placed and sized relative to other elements. Avoid Absolute Layout, which has been deprecated since Android 1.5 API Level 3. Absolute layouts do not scale across different screen sizes. Within your XML layout elements, do not specify width and height explicitly. Use the Android attribute values wrap content and match parent to dynamically size an element based on its content and its parent. Another way to provide an app that looks good on different screen types is to define multiple XML layout resources for different screen configurations. At runtime, the device reports its configuration, and Android chooses the appropriate matching layout resources for that screen. Defining multiple sets of layout resources enables you to create a single app with a flexible and adaptable interface for different screen configurations. Screen configurations can be defined by general screen size. Android provides 4 generalized screen qualifiers: small, medium, large, and extra large. All of the Kindle Fire tablets are considered large devices. Smallest screen width. The smallest screen width qualifier, added in Android 3.2, defines the width of the smallest side of a tablet in density pixel units. This qualifier takes the form of SW XXX DP, where XXX is the given width, for example, SW 600 DP. Smallest width is preferable to the general screen size qualifiers, as it enables you to more specifically target a given screen type. All of the Kindle Fire tablets support smallest width, except for the first generation Kindle Fire, which is based on Android 2.3.3. To define multiple layouts for different screen sizes, create layout directories within the resource directory in your project. Create them with suffixes that indicate either the general size or a smallest width qualifier. Place your layout XML files specific to those form factors within those directories. For example, you could create a layout and custom layout for large screen sizes within these two directories, Resource Layout and Resource Layout Large. Layout directories for the smallest width follow the same convention. All the smallest width qualifiers are in DP units, which are scaled to the density of the device and thus may not be the same as its physical width. For example, the Kindle Fire HD7 has a physical pixel width of 800 pixels. It is an HD device with 216 pixels per inch. In DP units, the width is scaled or divided by 1.5, resulting in a smallest width qualifier of SW533 density pixels. For layouts optimized for the Kindle Fire HD7 or similar devices, you could use this directory, Resource Layout-SW533DP. The table below shows the configurations for each of the Kindle Fire tablets, their generalized sizes, and smallest widths, as well as the actual pixel dimensions of the screen. Note that smallest width is not available for first-generation Kindle Fire, which is based on an older version of Android. Use a default layout or layout-large to specify a layout for this device. As with layouts and screen sizes, Android chooses the appropriate set of resources based on the configuration the device reports at runtime. Note that Android's generalized density qualifiers group similar devices together, which makes it easier for you to create layouts and graphics for devices in the same class. Keep in mind, however, that the density qualifiers indicate approximate densities, 160 dpi for MDPI devices, and 240 dpi for HDPI devices. The actual densities of each device may vary slightly. If you use these generalized densities, but build your user interface elements to have precise physical dimensions, you can still end up with unexpected results. For example, layout elements may be the wrong size or may become misaligned on the screen. Be sure to test your app on specific devices to ensure compatibility. Provide multiple graphics resources. Bitmap drawables, including icons, background images, and other graphics, pose a particularly confounding problem for managing the appearance of your app across screens with differing densities or aspect ratios. If you provide a single set of bitmap resources for one screen size or type, Android automatically scales those graphics to fit the devices, potentially with less than ideal results. Automatic scaling can result in distorted, fuzzy, or jagged-looking graphics, or even unreadable text. As with layouts, you can create multiple drawable directories within the Resources directory for your graphics resources and optimize your graphics specific to those configurations. You can name those drawable directories as you would layouts for both generalized and smallest width qualifiers. For example, Resources drawable-large. In addition, Android provides qualifiers for specific screen densities, dots per inch, that may be more useful for bitmaps. For screen densities, Android provides 5 qualifiers: LDPI, MDPI, HDPI, XHDPI, and TV DPI. In other words, low, medium, high, extra high, and TV DPI. For example, to provide both default set of drawables as well as drawables optimized for high-density screens, use these directory names, resources/drawable and resources/drawable-HDPI. You can also mix and match density qualifiers for drawables or layout with size or smallest width. Resources/layout-large-HDPI and resources/drawable-SW800DP-HDPI. The table below shows the configurations for each of the Kindle Fire tablets, both the generalized density and the actual density. For more information about the Kindle Fire screen sizes and densities, see the Kindle Fire device and feature specifications. even if you follow the previous guidelines for defining a flexible layout and providing alternate layout and graphics resources, you should also declare the supported screen sizes in your Android manifest file with the Support Screens element. For example, to explicitly indicate that your app supports only tablets, i.e. large and extra large screens, and those with a minimum width of 533 density pixels, use the code in the slide. Note, as with the smallest width qualifiers for resource directories, the requires smallest width DP attribute is only available on Android 3.2 or higher. Therefore, it is not available on the first generation Kindle Fire device. Understand how full screen modes affect layout. On the Kindle Fire tablets, your app can operate in one of three screen modes. Standard mode, in which a status bar and a soft key toolbar are visible on the screen. Full screen mode, which hides the status bar and minimizes the soft key toolbar. Only a small full screen handle is displayed. Users can view both toolbars by tapping the full screen handle or swiping up from the bottom of the screen. Super full screen mode, available in Android 4.0, Ice Cream Sandwich, or API level 14, also hides the full screen handle. No toolbars are visible on the screen. As with full screen mode, users can display both toolbars by tapping on the screen. The visibility of the status bar and soft key bar may have different effects on your layout, especially if you design your app for full screen mode. Specifically, in standard mode, the status bar and soft key bar displace your layout by the height or width of the bar. If you query the size of the layout with view get width or view get height, those values are smaller than the overall display because the layout takes both toolbars into account. In full screen mode, the full screen handle draws on top of your layout. In super full screen mode, no toolbars or handles are visible. In both full screen modes, when the user taps the screen to display the toolbars, both the status bar and soft key bar draw on top of your layout and obscure any elements beneath them. The size of your layout does not change. In this instance, if you query the dimensions of the layout, the Kindle Fire tablet returns the overall dimensions of the screen. Your app cannot control whether the toolbars are displayed in full screen mode. That behavior is up to the user. If your app's layout depends on the full screen being visible at all times, including when the toolbars are displayed, you should adjust your layout to take the size of the toolbars into account. You can find the size of the status bar and soft key bar for each Kindle Fire tablet in the user experience specifications. When coding for screen modes, keep in mind that the screen modes from Android SDK 2.3x to 4.0.3 may not appear exactly the same within the app due to changes in both the Android 4.0.3 platform and the Kindle Fire tablet skin. Pay particular attention to how a selected screen mode is ultimately rendered across the device versions and select the screen mode that best fits your use case. If one screen mode coding method does not fulfill your user experience requirements across the device types, consider enabling device detection and branching the code for that UX element. Apps have the freedom to hide the soft key area. Essential functions need to have accessible controls. When the app uses full screen, the soft key toolbar should be minimized with the full screen handle visible, and the settings toolbar should be hidden. The following example shows the flag for full screen mode and for super full screen mode. Many apps are derived from existing Android smartphone apps and do not scale well to the tablet form factor. We strongly encourage developers to create user interfaces that fully exploit the available screen sizes and tablet features. Optimizing your app for tablets allows you to optimize user engagement and can potentially improve your monetization opportunities. Exploit the real estate. Apps that are scaled up from a smaller screen size generally do not look as good as dedicated tablet apps and are feature limited when compared to a similar app designed specifically for the tablet environment. For example, many mobile phone apps are designed as a list of items, for example, postings and photos, that are linked to new pages. When viewed on a Kindle Fire tablet, these apps appear feature-limited compared to similar apps designed for a tablet environment. The lists do not fill the screen, nor do they take advantage of the potential user experience features. Apps designed to be multi-pane leverage the screen real estate so users can directly open content they'd otherwise have to page on a phone app. Optimize for dynamic resizing. Apps designed for phones tend to be created as portrait apps only. Apps designed for tablets are optimized to be viewed in portrait or landscape mode, providing orientation-specific layouts as demonstrated in the simple RSS reader sample and resized dynamically using the accelerometer to sense orientation. Apps designed primarily for use on phones can also suffer from significant degradation in graphics quality as the UI elements are dynamically scaled up by the Android platform to fit the screens of larger devices. Designed for interactivity. Apps designed for phones are intended to be used with one hand and provide single-point touch elements with larger touch targets to accommodate thumb navigation. In contrast, apps designed for tablets are developed using multi-point touch elements that can accommodate tablet users' normal two-handed pinch and zoom and swipe actions, providing a richer and more dynamic user experience. Apps designed for phones tend to provide a static representation of non-interactive content. Apps designed for tablets offer additional opportunity for interactivity and can help you extend the reach of your business by including partner content, such as ads or additional game offerings, as well as interactive applets as in a multi-pane design. Many developers overlook the need to update their code to take advantage of hardware acceleration. To enable the hardware-accelerated 2D graphics, you should edit the Android manifest.xml with the example shown in the slide. Please specify API level 11 as the minimum OS. Integrating Amazon Game Circle into your application gives you the ability to drive deeper engagement with your app. It provides leaderboards and achievements, which drive frequency of use and generates higher average revenue per user. One of the great new features that the Kindle Fire HD tablets offer is a set of dual-driver stereo speakers on both sides of the display. The sound setup opens new possibilities to game and app developers by allowing for a more comprehensive and immersive sound experience. With minor adjustments, any app can leverage the stereo speakers and enhance the user experience. By default, Kindle Fire HD uses both speakers to output balanced sound, left speaker equals right speaker. By changing the volume on either side, we can achieve an effect of localized sound. As a sample, we can consider a conga drum app. The app will have two conga drums displayed, one on the left and one on the right. Tapping on the left conga produces sound only in the left speaker, and similarly, tapping on the right drum produces sound in only the right speaker. The way to control the volume on the speakers depends on the method used to actually play sound. For the purposes of this example, we will assume that the media player class is used, but most other methods could be used similarly, if not identically in nature. The following code will create a media player instance that will play audio only through the left speaker. The left volume and right volume parameters can be set to any value between 0.0, which is off, and 1.0, which is full volume. The volume level is relative to the master volume of the device, so changing these values is basically just changing the balance between the stereo channels, or in this case, the two speakers. About the HD Designation Program. The benefits of participating in this program include an HD tag that's included in your app title. This lets customers know that they are going to have a great experience on the Kindle Fire HD devices with your app. The program requirements for the HD designation include that your app is designed for HDPI or better and references support for HDPI or better in the manifest. Images rendered are native resolution, either vector-based or not programmatically scaled up from smaller resolutions. The entirety of the screen must be used, no letterboxing, and video-centric apps with full-screen playback must be at least 24 frames per second and at least 720p in video-focused applications. If you would like your app to be considered for the HD designation program, please add the note, "Please review for HD designation" in the testing instructions when submitting your app. Providing a link directly to the Amazon Appstore for Android from within your app is an effective tool for promoting your apps. This type of link is referred to as a deep link and can be used for several purposes, including linking to the paid version of your app, linking to another one of your apps, and linking customers to the App Store to write a review for your app. The App Store will automatically pick up on specially formatted links through the use of Android intents. You have two options for providing a deep link. Option 1. Link to the Amazon Retail website. This type of link will be picked up by the App Store as well as any installed browsers on the device. The base URL is as shown in the right-hand column of this slide. Option 2 is to link directly to the Amazon App Store. This specially formatted link is the preferred method and will directly open up the App Store on your device. The base URL is as shown on the center column of the slide. You can modify the URI by adding parameters as shown in the slide below. Now you're ready to get started. I'm glad that you've had a chance to learn about the Kindle devices, Kindle device compatibility, and Kindle device optimization. For additional resources and to learn more about our APIs and ecosystem, please go to developer.amazon.com/welcome. If you'd like to ask a question or get more help, please feel free to contact us on our forum or the Contact Us link listed here on the slide. To get the latest news about APIs, services, and features, you can follow us on Twitter, Facebook, or on our blog. Thank you very much.